Activity 4, you learned another definition of congruent figures. This definition involves the measurements of sides and angles of a figure. For example, if two triangles have sides of lengths A, B, and C, then the triangles are congruent. Congruency can also be shown when two triangles each have two sides of the lengths A and B, and the angle between the two sides is the same in both triangles. Math tip. Two triangles are congruent by SAS, side, angle, side. If two figures are congruent by one of the two definitions, are they congruent by the other definition as well? As you will see, the answer is yes. Line segment A connects points 2, 3, and 5, 3. Line segment B connects points 1, 0, and 1, negative 6. Here in this section, we're going to do questions number 13 to 16. 13 says, find a composition of two rigid motions that maps line segment B to a line segment B prime that overlaps line segment A. What pair of points does line segment B prime connect? Can you add a third rigid motion to the composition that maps B prime and explain why or why not? In the composition you identified, what subsection of the line segment B maps onto line segment A exactly? And what is the length of this subsection? For this particular set of problems, I am going to give you a 10-minute time limit to work through questions 13 through 16. Please go ahead and pause your video for 10 minutes time. All right, so as you can see, 13 through 16 have been provided. I said if we were to first rotate this particular line segment 90 degrees this way, counterclockwise, it would be, and I rotated about the point 1, 0, so it would have ended up here, something like this. And then I want to translate it 1 unit to the right and 3 units up, so it will now be up here. Okay? It says, what pair of points does line segment B prime connect? Well, if you recall, line segment B was 6 units. So that means that line segment B prime should also be 6 units. And if I have one endpoint at 2, 3, that means that the other one has to be at 8, 3, because I added 6 for the 6 units. It says, can you add a third rigid motion to the composition that maps B prime and explain why or why not? Well, no. And the reason that is the transformation would either condense the longer line onto the shorter one, which is not a rigid motion. Recall that rigid motion is translating, rotating, or reflecting, and that would need to involve a dilation, and that's not rigid because it changes the size. In the composition you identified, what subsection of line B maps onto segment A exactly? What is the length of this subsection? Okay, well, recall that this one is only 3 units. So the 3 units covered in the original would be from 1, 0 to 1, negative 3. And that length is 3 units, which is the same as line segment A. On to your final debriefing question.